Professor H, and today we are going to be talking about several different topics involving water, because it's water, water everywhere. It's the name of the class, so of course we're going to be talking about water. Now, when you have had a cold glass on a hot day, you may have noticed that if you're not real sure what's going on, your glass seems to be leaking. There gets water all along the sides of your glass and even underneath. That's why I've got a little cloth here to protect my table. So where's this water coming from? It's not coming from our glass. I mean, the glass doesn't have any holes in it. When it's dry, you don't see any holes. So where's it coming from? It's coming from the air around us. That's right, the very air that we breathe has water vapor trapped in it, which is little droplets of water that aren't big enough to be water by themselves. They're just little tiny droplets. They float around. They're all in the air, and they come to the glass. Why do they come to the glass? The coldness of the glass is enough coldness that when the water in the air comes by and it hits the glass, it feels the chill of the glass and it condenses or gathers on the glass and makes water that we can actually feel. Now, we got a little practical thing we can do with this. We're going to make Professor H's temporary glue. This is not on your supply list. This is the last bonus. I have here a glass. It's totally dry. There's been nothing in it. I've got here just a plain piece of paper. Nothing special. Just cut it a few minutes before we started filming. If I take this piece of paper and I try to wrap it around this glass, I bet you know what's going to happen when I let go. It fell. That's because gravity, the force that makes things fall, makes it fall. It actually makes it fall at 9.8 meters per second squared, or 32 feet per second squared, but that's a different class called physics. So, gravity's making it fall. Well, what can we do? Well, we're going to turn this into glue. How are we going to turn this into glue? We're going to use water glue. That's right. Water can be glue. First, we're going to take our piece of paper and wrap it around our glass and get it nice and damp from nothing but the condensation on our glass. Then we're going to peel it off. Do the exact same thing on the other side of the piece of paper because we want it real damp. If you've ever had a piece of paper stick to you when you were sweaty, this is why it does it. Then we're going to put it on our glass, do it a little press. Nope, I didn't get it wet enough. You can tell because when you put the paper up, if it's already dried, you didn't get it wet enough. So we're going to sit it there for a minute and let it get nice and damp. Now, let's talk about water and its other states. Water, like all matter, can be in 3 states. Now, what is matter? Matter is basically everything around you that's not energy. And energy is heat and electricity and things like that. Matter is all the stuff you can touch, taste, see, and feel. So, matter has 3 states. It can be a solid, a liquid, or a gas. A solid means just what it sounds like. It's solid. When you move it around in this container, it keeps its shape. It floats around in there as you move it, but it doesn't become anything else. It's just a solid. And in this case, water as a solid, you've seen this before, I'm sure, is called ice. It's just a fancy name we gave it when it's a solid. But it's still water, and if you let it melt, it will turn back into liquid water because ice needs to be at 0 degrees Celsius or 32 degrees Fahrenheit. Now, Fahrenheit's the scale that most of the United States uses, and Celsius is the scale that pretty much the rest of the world uses, and scientists in America use Celsius as well. One of the reasons they use Celsius is because Celsius is built around water. 0 degrees Celsius is the freezing point of water, and 100 degrees Celsius is the boiling point of water. So the Celsius scale is actually built to show when water changes state. Below 0, it's a solid. Above 100, it's a gas. From 0 to 100, it's what we usually think of it as a liquid. So, while our little solid there is melting, we're going to pull it out, throw it over to another glass. And we're going to take just a little bit of this water and pour it in here to show you something. Whoa, there we go. Okay, when you've got water in a container or any liquid, it will slosh around. What it will do is it will fill the bottom of the container first, and then it will start to go up the sides as much as it can. But it won't fill the entire container unless you got pouring in the water. But the final state of matter we're going to talk about, called a gas, has really neat properties. If I take this glass and I put my hand over it, you can see that there is a space between the water to the top of my hand. In that space, that's not empty. There's a gas there. The gas that's in there right now is air, which is mostly nitrogen and oxygen. but we're not going to get into air right now. Again, that's another class. We're talking about water. And in water, the gas is called steam. And we're going to make some steam in a little bit. But right now what I want you to realize is a gas fills the container from bottom to top, all sides. It totally fills the container. It just spreads out until it can completely fill the whole container it's sitting in. So that's the three states. Again, you've got a solid, which is our ice, liquid, which is water when we normally think of it, and finally, steam or gas. Okay? Let's see if our glue's ready to work. Peel this off. Bring our little glass back over here. Stick this on, and voila! Professor H's temporary glue. So, one last thing about water. How does it change from ice to a liquid to steam, which we don't have here, but we'll imagine. In order to do this, it needs energy in the form of heat. Now, you've probably heard of heat before. When it's hot, you say, hey, it's heat outside. Or if your mom or dad's got a heating pad, maybe you've used it when you had a sore muscle. What is heat? Heat is nothing more than energy in motion, or energy moving. When heat is moving from one to another, energy is moving. Have you ever ran outside or been on a hot summer day and you start to sweat, and as you start to sweat, you cool off? Well, the way you do that is real simple. The water or the sweat comes out of your pores and it sits on your skin. Then, as the wind or the air blows by, the water is taken from your skin. As it's taken from your skin, in order to move from your skin into the air, it needs heat. Guess where it gets the heat from? It gets it from your body, and that's what cools you off. The fancy term is latent heat of vaporization, but you don't have to worry about that one. That's just the fancy term. The simple term is sweat makes you cool. And the reason sweat makes you cool is because it comes off your body, and as it leaves, it takes some heat with it, which cools you off. And that is also why our glass gets wet, and that is why if we left this here long enough, let me take off my glued paper here, you will see that this ice is already starting to melt pretty quick. And if I was to pour a little water in there, it would melt faster, because that's when we get into heat transfer. But then again, that's not what we're going to talk about today. So, I hope you've enjoyed our little lesson about our friend water and its different states, ice, liquid, and later on we're going to learn more about steam. And remember, heat is just energy in motion, and we also talked about temperature, and we didn't define temperature. You probably know what temperature is when your mom says, oh, it's 70 degrees outside, you don't need a coat, or it's 30 degrees outside, you do need a coat. But what is temperature? Well, a fancy definition for temperature is the measure of the relative average molecular kinetic energy. Now, I don't expect you to know what all that means. I had to go to the Navy and go to nuclear power school to learn what that meant. But a real simple way to think about it is, inside this ice and inside everything are a bunch of little tiny particles called atoms. But we're not going to learn about atoms. Just know they're little tiny things that we can't see, and they're atoms. And they move around. They're zooming all around. We can't see them zooming, but they are. Well, how much they zoom around and the measure of how much they zoom around, that's temperature. And the hotter something is, the more those little guys like to zoom, and the colder it is, the less they like to zoom. So when you're done with your experiment, with mom or dad's permission, have a drink of cold water, and I'll see you around.